Finally, it happened. The Odysseus lunar lander has landed on the moon, but there is a catch. It is sideways. Yes, you heard that right. The lander, which was supposed to make history as the first US and private lunar landing since 1972, ended up tipping over on its side after touching down on a rocky area near the lunar South Pole. What does this mean for the lander and its mission? Is it still working? Can it be fixed? In this video, we will answer these questions and more by looking at the latest news and facts from official sources. We will also discuss the positive and negative aspects of the lander's situation and what are the possible solutions and outcomes. So, stay tuned and don't forget to subscribe and hit the bell icon for more videos like this. The Odysseus lunar lander was launched on February 16, 2024, aboard a SpaceX Falcon 9 rocket from Cape Canaveral, Florida. The lander was part of NASA's Commercial Lunar Payload Services program, which aims to support the development of moon landers by private sector companies. It had a mass of about 600 kilograms and carried 11 payloads, including 6 of NASA instruments, such as a laser reflector, a magnetometer, a camera, a radiation sensor, and a navigation system. The lander also carried a small lunar rover named Iris, which was supposed to deploy after landing and explore the surroundings. The journey to the moon took about 6 days, during which it performed several orbit adjustments and maneuvers. On February 22, 2024, the lander began its final descent to the lunar surface, targeting a landing site near the Shackleton crater at the lunar South Pole. This region is of great interest for lunar exploration because it has areas of permanent darkness and sunlight, which could harbor water ice and other resources. The descent was autonomous, using its onboard sensors and thrusters to navigate and slow down. It also transmitted live video and telemetry data to Earth via a relay satellite orbiting the moon. However, something went wrong during the last few seconds of the descent. According to the data and images from the lander, it encountered an obstruction on the lunar surface, which caused it to bounce and roll over. It ended up tipping over on its side, about 30 meters away from its intended landing spot. The antennas, which were supposed to point upward, were now pointing downward, and its cameras were partially blocked by the lunar terrain. The rover, Iris, was also trapped inside the lander, unable to deploy. Moreover, some of the landing legs were also damaged, and some of its payloads were exposed to the harsh lunar environment. Despite the sideways landing, the lander was not completely doomed. In fact, there were some positive aspects of the lander's situation, which gave hope to the mission team and the lunar community. The first and most important thing was that the lander survived the landing and was still functioning and communicating with Earth. The power system, which consisted of solar panels and batteries, was still working and providing enough energy to operate the lander's systems and payloads. The thermal control system, which regulated the lander's temperature, was also working and keeping the lander within safe limits. Moreover, the computer and software, which controlled the lander's operations and data processing, were also working and executing the lander's commands and tasks. The second positive aspect was that most of the lander's payloads, including the NASA instruments, were still functional and exposed to the lunar environment. The lander might be able to collect and transmit data and images from the lunar surface, using its remaining cameras and sensors. It might also be able to perform some of the scientific and technological objectives of the mission, such as measuring the lunar magnetic field, the radiation environment, and the distance to Earth. It also carried a laser reflector, which could be used by other spacecraft and telescopes to measure the lander's position and the lunar orbit. The third positive aspect was that the lander's sideways orientation did not affect its communication with Earth. It was able to use its relay satellite, named Novalink, to send and receive data and commands to and from the Mission Control Center in Houston, Texas. It was also able to use its direct-to-Earth antenna, which was mounted on the side of the lander, to communicate with Earth stations around the world. The communication system was vital for the mission, as it allowed the mission team to monitor the lander's status and performance, and to adjust the lander's operations and activities.